Okay, we're ready to finally finish up. This is going to be preparing, screening, cleaning your data, part two, or subpart two. So again, we've divided part two up into two subparts. We finished with the first subpart. In the second subpart, we're going to look at graphs and visuals and visualization. So that's going to be our subpart two of part two. Okay, so again, this is subpart two. This section deals with graphs, charts, and visuals. I will say that visualization, charts, graphs, etc., not really my thing. I do tend to do better looking at numbers. With rare exceptions, I find charts and graphs confusing. I often and I've seen other people make the same comment. People spend a lot of time and effort on visualization, but then it doesn't look right on a smartphone, or it doesn't look right when it's projected in a big room, or something else happens. And so I tend to think people overemphasize visuals. On the other hand, I'm not a visual person, so probably not to get into learning styles, but maybe not a visual learner. So uh, just because it's not my thing doesn't mean it's not important. And I'd also say, certainly again, if you go online, you can find people who really are into talking about and experts in these types of things, including one of my former graduate students. But we're just going to go through it pretty quickly here. So we're going to start out with scatter plots, because scatter plots are very important in regression. And this is a particular scatter plot, again, is for anxiety and exam performance. It looks at 103 students. The measures were time spent revising, the hours, or time spent revising, exam performance has a percentage, and again, you probably shouldn't use percentage score as a measure, but this one does. Exam anxiety, score out of 100, and gender. And this is not my scatter plot. This one comes from field, I believe. Even though I don't see the field background, maybe somehow I deleted that. So when you go to select scatter plots, again, you go into SPSS. There's a graphs option. You can go to scatter plots. You can see there's a whole host of different kinds of scatter plots you can choose, from simple scatter plots, 3D scatter plots, scatter plot matrices. So there's a lot of different choices for scatter plots. Also, what sort of is confusing in SPSS, after you create your plot, if you then go to edit it, you get even more additional options. For example, if you go to edit a scatter plot, you can add a regression line to it and things like that. So not all the options are in your original graph creation. Some of the options are when you go in and try to edit the graph after you create it, if that makes sense. So it's often a two-step process: creating your graph, and then if you click on your graph in the output, and it sort of opens it in an editor, and now you can do more things to it and improve it. But anyway, a simple scatter plot. Again, this is from SPSS. Here's a simple scatter plot, exam anxiety and exam performance. And you can see it's just plotting those data points there for you. This is just a very basic one, a simple scatter plot. Here's another simple scatter plot. In this one, we can see that there's actually a negative relationship. I think, unfortunately, PowerPoint cuts something off. But yeah, I mean, you can still see the main point, that there's a negative relationship. And actually, in this case, you can also see, let me get my pointer here for a second. You can also see that it actually calculates the regression line and gives it to you. So it actually calculates this regression line and gives it to you as part of this simple scatter plot. Here's what's called a group scatter plot. It's using biological sex. One sex is green, the other sex is blue. And so you can see that in this particular chart preview that it's doing a grouped scatter plot. Again, all these things are available in SPSS. Fields discusses them in his book. Even though these don't have the field background, these are from field originally. Okay, and then this is a group scatter plot. You can see it's put the regression line on it. So this one's between exam anxiety and exam performance. You can see as anxiety goes up, exam performance goes down. And you can see there's one regression line for males and one for females. So this is the male regression line in blue. This is the female regression line in green. I would note, though, just because they look different doesn't mean they're significantly different, of course. One of the things we would use statistics for is to see, is there a difference in these two scatter plots? So is there an interaction with sex? In this case, it looks like there might be, but that doesn't mean it's actually significant. But anyway, so we get a regression line for males and a regression line for females. We can also get what's called a matrix scatter plot. A matrix scatter plot just does a lot of different scatter plots in different boxes. I guess that's the best way to describe it. In this case, it's going to be time spent revising, exam performance, and exam anxiety are all going to be put into this scatter matrix. And then here we can see the matrix scatter plot. So you can see the diagonal, of course, is empty. This would be time spent revising and exam performance, time spent revising and exam anxiety. Of course, exam performance and exam anxiety, exam performance and time spent revising. And finally, exam anxiety with time spent revising and exam performance. Okay. Okay, we're going to look at my COVID data set really quickly here. So I again chose, just to show you what some graphics look like for the COVID data set, I chose Analyze Descriptive Statistics and Explore. You can see I created a scatter plot. I mean, again, we only have 50 cases. They're states. My scatter plot on the bottom, this is actually population, which I then stopped using, but this is population and total deaths. And before we saw that, we haven't seen it, we're going to see it actually, that neither total deaths or population are very normally distributed. But so this is just a scatter plot of total deaths by population. As you might expect, as population goes up, the total deaths goes up. The R squared is 0.725. There's two sort of values that are pretty far from the mean, but in general, as population goes up, total deaths also go up. A couple sort of outliers away from this regression plot, they would have big residuals here. But in general, it looks like a pretty straight line relationship between population and total deaths. Probably not unexpected. This is just a histogram of the population data, and as you can see, it is quite skewed. We can see we talked about having before outliers, but the mean is pretty far to the left-hand side here. It's not a very normal distribution. And we have some outliers in this tail. This is total deaths. Now, you can see the same thing occurs with total deaths. I said earlier, though, one of the unique things is when two variables have similar skewness, as these two variables do, it's actually beneficial in that they're going to match up better. So two data points with two variables with very different degrees of skewness are not going to be able to match up very well, and so they're not going to have a very high correlation coefficient. But if two variables are similarly skewed, then you're going to be able to get maybe not a correlation of 1, but a higher correlation. So in this case, probably one of the reasons we do get a pretty high correlation between total deaths and population is that both have a similar degree of skewness. Both have means that are at the leftmost end, and they have some outliers towards the right-hand tail. They're not very normal distributions again. Not at all. Both are heavily skewed. Now you can see, as again I said, as I moved on in the rest of the semester, we're going to be using deaths per population as the main outcome variable. Now, of course, it's not perfectly normally distributed. We only have 50 cases. Well, you actually see here we still had 51 cases. I had not gotten rid of Washington, D.C. yet. So at this point, we still have the District of Columbia included, or Washington, D.C. But you can see that the deaths per population is much more normally distributed than was either the death data or the population data. So it comes closer to being a normal distribution. And then this is the PP plot for total deaths. Again, plotting the observed cumulative probabilities versus the expected cumulative probabilities. And you can see that it's very, very off of that straight line. So it's not very close to that straight line at all. Here is the plot for death per population, or deaths per population. You can see those come a lot closer to that straight line. So if we compare it to the last chart, which is hard to do here when I'm recording the slides, but if I was to go back and compare to the last chart, this one is much closer to normal data, a normal distribution. And we can see that because it's much closer to this straight line than was the last data. Okay, again, that brings us to the end, though, then. Thank you for sitting through our discussion of cleaning data, preparing data, screening data, graphs, visualization, for sitting through parts 1 and part 2, subpart 1 and part 2, subpart 2. I hope you got through all the parts. Again, if you need to email me to ask any questions, you can reach me at dennisdoverspike@gmail.com. Thank you very much. And that's it. That's the end. This, by the way, is Zippy, the University of Akron mascot.